Oh, yeah. Okay, so we're going to do question 15 now. It's a helicopter question, so you want to draw the helicopter, like so. There's your helicopter. Thank you. I know. So, a helicopter can fly 75 meters per second in still air. Let's just put that piece of information down. The pilot wishes to fly from airport A to a second airport B, 300 kilometers due north of A. So let's draw our little. Yes, man. Oh, sorry. Let's draw a little diagram here. So that's A, and we're going to go to B. So we plan to fly like this. Question A says, oh, look, there's no wind blowing. There's no wind blowing. What should my velocity be in terms of the component form? Well, if there's no wind blowing and we're going directly north, then there's only a vertical component and a positive vertical component, and that's going to be 75J, 0I. You okay, Alan?
Yeah.
Okay. You seem really stressed out.
No, it's just
Okay. Yeah. Be careful. Take some rest, okay? Anyway, so we have the question says find the time the journey will take. So we got meters per second, so we're going to convert our distance, which is 300 kilometers, to meters. As you know, there are 1,000 meters in 1 kilometer, and then we go time equals distance over speed from physics. So we go 300,000 divide 75. And it should give us 4,000 seconds. Anybody confused yet? So 4,000 seconds, we can convert that to hours and minutes if we want to, but I'll leave that up to you. Question B though is a little bit trickier. And here's what it says. There is a wind of 21I and 10J meters per second blowing. So now the helicopter has to counteract this wind and make sure that it stays on the path. So let's just draw it in. Let's use a different color pen.
I'm assuming that's going in that direction.
Well, let's see where the wind's going. Let's see where we have to actually go. Alright, so I'll do it in black. There's a wind going this way. Alright, this wind is 21I plus 10J. Are we in the right direction? Yes, positive, positive. So obviously our plane has to fly this way. So our helicopter has to fly this way so that we end up at B. Now before we do anything, here's where the thinking part comes in. We're going from A to B, so we're going north. So before we do any mathematics, can we find the I or the J component immediately? J, find the I component immediately. Why? How so? Hi, Mr. Marlin. Is that going? Yes, Brendan. Everybody loves your shirt. Okay, so we have to counteract this wind, but because we're going north, we know that the I component has to bring it back to north. So if that's positive 21, it has to be negative 21I. because it has to bring it back to north. Do you see it? And then we have to solve for b.
Wasn't it just like 75 to 1?
No, because 75 is the speed. So you are correct as in the magnitude of this is going to be 75. In other words, negative 21 squared plus b squared square root is going to give me 75. Like so. Now I do some algebraic manipulation. And I find that b can be a positive number or a negative number. So let's do that very quickly. You can use solve in your Casio. My Casio's died, yes it has. Sorry, I've got multiple. So we go square root, and check your answer with me. Please don't just trust me, you know. So positive or negative? Positive or negative 72. Now let's once again look at the diagram. Well, negative 72 means that it's going down, and we can't go down. We need to go upwards. So this b has to be, this b cannot equal to negative 72. So therefore it has to be 72 based on my diagram and the application of the question. So now we have our speed as negative 21I plus 72J. What now? We need...
That's the magnitude of
Yes. So we've done the hard bits. Let's find the time it takes. So how do we find the time it takes? Well, first we need to work out our resultant of this. So let's find the resultant. What's my resultant going to be? Anyone? Motivation box coming out? Sorry, Brendan? Brendan, how'd you get 82J? Yeah, so you have to add this vector there with this vector to find the resultant. So in other words, 21I plus 10J plus negative 21I plus B, sorry, plus 72J. And that leaves me with 82J. Which means my magnitude is 82 squared square root 82. Therefore I can do the same thing.
So why is it faster when it's pushing in the other eye?
Yep, so you have to. Sorry, Matthew?
just figuring out how you got 82.
So the square root of 82 and then the squared.
Yeah.
So we go distance, that's 300,000 over 82. That should give us our answer. And then you can simplify that to minutes and hours. Questions?
How fast is it travelling in kilometers per hour? Helicopter.
So you can convert the 75 meters per second
Yeah.
to kilometers per hour by multiplying it by 3.6.
Yeah.
So multiplying this by 3.6,
That's actually 20 kilometers per hour.
Exactly.
Yes. 270 kilometers an hour, which is quite average for a helicopter.
It's because